Hello everybody. So we'll be starting the numericals or problems on equilibrium of forces. So we have to use the concepts which we went through in the previous video in order to solve the numericals. We went through the concept of equilibrium of forces. I mean the conditions of equilibrium, have three conditions of equilibrium. And we went through the concept of Lami's theorem, and also we went through the concept of free body diagram. You have a number of steps to draw the free body diagram, and you need the concept of free body diagram to solve the numericals. Here, in all the problems of equilibrium, you will be finding the unknown force. You'll be given with an unknown force in the question, and you are supposed to find the unknown force. The problem will be basically on finding the unknown force. Unknown force. See, in the concept of free body diagram, we went through a number of hidden forces as well. So you have a number of hidden forces like self-weight, which will not be given in the problem. You should know how to mark self-weight. Normal reaction offered by the surface. If a body is in contact with the surface offers a reaction, and we call that reaction as normal reaction. We went through this in the previous video. You should know how to mark the normal reaction. And if a body is being connected to the surface with the help of a string or cable, there is a tension or force which runs through the cable. You should know how to mark the tension or force through the cable. These are the hidden forces. So basically, you'll be asked to find one of the unknown forces, and you'll be finding the unknown force here in all the problems of equilibrium. So there are several steps to remember in order to solve the problems related to equilibrium. All the problems of equilibrium are solved using these steps. Let us go through the steps one by one. Step number one is to draw the free body diagram. Step number one is to draw the free body diagram. Again, when you draw free body diagram, you have several other steps which we went through in the previous video. So here, in solving the problem, step number one will be drawing the free body diagram. And again, to draw the free body diagram, you have a number of sub-steps. To draw the free body diagram, again, you'll be locating the center, then you'll be drawing the coordinates, you'll be marking the self-weight, you'll be marking the normal reaction, you'll be marking tension through the string, then finally you'll reproduce the coordinates along with the forces systematically. You bring all the forces to the center and you'll draw the free body diagram. These are the steps which are involved in drawing the free body diagram. But here, to solve the numericals, the first step is to draw the free body diagram. Now, step number two. So if you have three forces in the drawn free body diagram, you have to observe the free body diagram. If you have three forces to solve the problem or to find the unknown force. If you have more than three forces, you cannot apply Lami's theorem. Lami's theorem has a small limitation. Lami's theorem can be applied for an equilibrium force system with only three forces. So, in step number one, you'll draw the free body diagram, and in step number two, you'll just observe the free body diagram. By observing the free body diagram, if you find that, or if you have only three forces, you can straight away apply Lami's theorem to find the unknown force. Or if you have more than three forces, you cannot apply Lami's theorem. Instead, you have to apply the conditions of equilibrium. Which are the conditions of equilibrium? You have three conditions of equilibrium. 1, 2, and 3 conditions. Summation of Fx equal to 0. Summation of Fy equal to 0. And the moment about any point is equal. By applying the conditions of equilibrium, we'll be finding the unknown force. That's it. You just have two steps here. Very simple. You just have two steps. Step number one is to draw the free body diagram. Drawing free body diagram is a major step here. If you commit any mistake, if you make any mistake in drawing the free body diagram, then step number 2 will depend on step number 1. Step number 2 will depend on step number 1. In step number 2, you'll either apply Lami's theorem or you'll apply the conditions of equilibrium. You'll either apply Lami's theorem or you'll apply the conditions of equilibrium. This depends on the free body diagram. Just by observing the free body diagram, you'll be in a position to decide whether to apply Lami's theorem or to go with conditions of equilibrium So step number 1 is very critical here and very important as well. So you should know how to draw the free body diagram very well. So in step number 1, you'll draw the free body diagram. In step number 2, you'll observe. If it has 3 forces, go with Lami's theorem. If it has more than 3 forces, apply the 3 conditions of equilibrium. These are the 2 alternatives in step number 2. Either this or this. Either Lami's theorem or conditions of equilibrium. So that's it. You'll be using these 2 to find the unknown force. Unknown force given in the problem. That's it. Steps are very simple. You just have 2 steps here. But to draw free body diagram, again you have 5 steps, 5 sub-steps here to draw the free body diagram. Hope the steps are clear. Let us start solving the numericals. Let us start solving the problems straight away. So I'll solve around 3 problems from the notes, 3 important problems. You have around 6 problems there. You have to solve the other 3 on your own. Let me solve the first problem, first numerical problem in your notes, which is this. Find the tension in the string and the reaction offered by the contact surface for a cylinder of weight 1000 newtons as shown in the figure. This is the question. I'll draw the question. This is how it goes. This is the given arrangement. You have a cylinder here, and this particular cylinder is being tied. This is the surface, and the angle given is 50 degrees, 50 degrees. And this angle is given as 30 degrees. This is the given question. This much is given to you. So what are you supposed to find here? You are supposed to find the tension through the string. This is one of the hidden forces, tension through the string. And the second thing which you're supposed to find is the reaction offered by the contact surface, normal reaction. Again, one more hidden force. Given that the self weight of the cylinder as 1000 newtons. You have 3 hidden forces, self weight, normal reaction and tension. Out of which self weight is given, you're supposed to find normal reaction and tension. You have 2 steps. Step number 1 is to draw the free body diagram, and in step number 2, you'll be applying either Lami's theorem or conditions of equilibrium depending on the number of forces. Here you have no external forces acting. On the body. So let us start solving the problem. You have to find what to find. There are 2 unknown forces to be found. Tension through the string and normal reaction R, or you can write it as NR as well. You have to find this, and you are given with the self weight W as 1000 newtons. You have this. Let us start solving. Step number 1 is to draw the free body diagram. Again, you have several sub-steps to draw the free body diagram. Let us start drawing the free body diagram. So step number 1 in drawing the free body diagram is to locate the center. This is the center. Is to locate the center and to draw the coordinates. Yes. The x-axis, this is the y-axis. So I have located the center and I have drawn the coordinates now. So this is step number 1. What is step number 2? Step number 2 is to mark the self weight. Self weight will always move vertically downwards. You have to remember these conditions. Self weight will always move vertically downwards. Self weight W is given as 1000 newtons. You know. So after marking the self weight, you'll be marking the reaction offered by the surface on the body. Reaction offered by the surface is also called as normal reaction. Normal reaction will always be perpendicular to the surface, will be directed towards the body, and will be acting exactly at the point of contact between the body and the surface. These are the 3 conditions to draw the normal reaction. So normal reaction should be perpendicular to the surface, directed towards the body, and it should act exactly at the point of contact between body and the surface. Let me mark this as normal reaction, N, R, or R. You can mark it as R as well. So this is the second force to mark when you draw the free body diagram. And the next force to mark is the tension. Tension will always move away from the body. Tension through the string will always move away from the body. Now, so you have marked all the forces now. Next step is to rearrange all the forces and redraw only the coordinates and forces separately. In the next step, in step number 5. We are done with step number 4 as far as drawing the free body diagram is concerned. Now let us rearrange. I'll just rearrange it here itself in the question. Now, the original position of normal reaction is in the 4th quadrant, if I'm not wrong. 4th quadrant, right? So you can apply, I'll just draw the line of action of normal reaction. You can apply the principle of transmissibility and you can push this normal reaction to 2nd quadrant. The original position is this. You'll be pushing the normal reaction to the 2nd quadrant. This will be the new position of normal reaction. Now, if this is 50 degrees, this is however perpendicular 90, so this angle will be 40 degrees. This angle will be 40. So if this is 40, even this angle will be 40. Right? Now, so we got the inclination of normal reaction with respect to horizontal, but we don't know the inclination of tension T with respect to horizontal. Now, let us find the inclination of tension T with respect to horizontal. Now, this line is perpendicular here. If this is 30, if this is 90, this angle between tension T, observe here properly, angle between tension T and the line of action of normal reaction is, if this is 30, 90, this will be 60 degrees. 60 degrees the angle between tension T and normal reaction, not angle between tension T and the horizontal. 60 degrees the angle between tension T and the normal reaction. So we got this much now. Let me reproduce the same. Only by drawing the coordinates and forces systematically. We'll draw the coordinates. Yes. Now, self weight is to be marked here. This is self weight. W is equal to 1000 newtons. Now, original position of normal reaction is in the 4th quadrant. This is the original position of normal reaction. Originally, normal reaction was here, but we have applied the principle of transmissibility and we have drawn normal reaction in the 2nd quadrant. This will be normal reaction now, making an angle of 40 degrees. Now we have tension T here. We don't know this angle. This is unknown. Angle made by tension T with respect to x-axis is unknown. We don't. But angle between tension T and this extended line of normal reaction is 60 degrees. This angle is 60 degrees. This angle is 60 degrees. Right. Now, if this angle is 60 degrees, everybody observe. Now this is 40, so even this will be 40, opposite angles, 40. So what will be this unknown angle? What will be the value of the unknown angle? So 60 is the angle made by tension T with respect to the extended line of normal reaction. So this extended line of normal reaction makes an angle of 40 with respect to horizontal. So the angle made by tension with respect to horizontal will be 60 minus 40, which is 20, which is 20 degrees. So this is the unknown angle which we need. Angle made by tension T with respect to horizontal is 20. 60 minus 40. Hope this is clear. A very simple calculation of angles. This is 60 degrees. This angle, as we went through the concept here. This is 60. This is 90, 30, and 60. 60 is the angle made by tension T with respect to normal reaction. Tension T with respect to normal reaction. The old position of normal reaction. We have pushed the normal reaction to the second quadrant. So this is 60 and these are the two opposite angles, 40 and 40. So 60 minus 40 will be 20. So this is the free body diagram. This is the free body diagram. Let me draw it once again. Let me draw the free body diagram once again by eliminating all of these angles, and let us draw the free body diagram with the necessary angles only. I'll rub the question. I'll draw the free body diagram properly. This is the free body diagram. I'll draw it once again. Newton force, W is equal to 1000. I'll draw the new position of normal reaction only. Normal reaction makes an angle of 40 degrees and tension T, which makes an angle of 20 degrees. We found this in the previous steps. So this is the actual free body diagram of the given problem. I love this. This is the actual free body diagram of the given question. So we have drawn the free body diagram. We got the free body diagram. Now just observe how many forces do we have in this particular free body diagram. We have 1, 2, and 3. We have 3 forces in the free body diagram. Only 3 forces. So if you have 3 forces, what are you supposed to do? You just have 2 ways. You just have 2 ways in step number 2. Either you have to apply Lami's theorem or you have to apply the conditions of equilibrium. You will be applying Lami's theorem if you have 3 forces. If you have more than 3 forces, you will be applying the conditions of equilibrium. Now you have 3 forces here, 1000 Newton, T, and normal reaction. Only 3 forces. You can straight away apply Lami's theorem. And you have to find T and normal reaction as per the given question. These are the 2 unknown forces, and you have to find the unknown forces using Lami's theorem. You can straight away apply Lami's theorem because it has 3 forces only. So applying Lami's theorem for the free body diagram, Lami's theorem goes in this way. NR, normal reaction, divided by sine of angle between the other 2 forces. T and W are the other 2 forces. This is 90, this is 20. So angle between the other 2 forces will be 90 plus 20, which is 110 degrees. So this will be sine 110 is equal to T divided by sine of angle between the other 2 forces. T divided by sine of angle between NR and W. This is 40, this is 90. So total angle between NR and W will be 130. So it will be sine 130 is equal to finally 1000 by sine of angle between the other 2 forces. Angle between normal reaction and T. This angle. So total angle is 180. So the left out angle, the final angle will be 120. So this is 40, this is 20, and this will be 120. So this is Lami's theorem. Lami's theorem states that again, a particular angle is proportional to the sine of angle between the other 2 forces. So NR divided by sine 110. 110 is the angle between T and W. T divided by sine of 130. 130 is the angle between W and NR. 1000 divided by sine of angle between the other 2 forces, NR and T, which is 120. So this is the statement of Lami's theorem. Here we know this fact, this particular term. This is 1000 by 120. This has no unknowns, but in these 2 terms we have unknown forces. Now equate these 2 and consider this as equation number 1. Equate the first unknown with the known and equate these 2 and consider this as equation number 2. As simple as that. Equate both the unknowns with the known term. Equate this particular term with the known and consider it as equation number 1, and equate this particular term with the known and consider this as equation number 2. Just equate this and this. Now let us consider equation number 1. Let us consider equation number 1. Equation number 1 is t by sine 130 is equal to 1000 by sine 120 is equal to 1000 by sine 120. In this particular equation, 120, 1000 into sine 130 divided by sine 120, which will be 884.5 newtons. You got the value of T, or you got the value of one of the unknown forces. So using the second equation, second equation is normal reaction NR divided by sine 110, which is equated to the known term, which is 1000 by sine 120, 1000 by sine 120. So using this, NR is the only unknown here. Using this, you can find the value of normal reaction. Normal reaction will be 1000 into sine 110 divided by sine 120, which will be 1085.06, 1085.06 Newton. So this is the normal reaction. So you got both the unknown forces here. You got both the unknown forces as per the given question. So hope you are clear with this particular problem. You have one more problem of same type. Second problem is of same type. You have the mirror image of the mirror image of this particular problem. So please go through the second problem and try to solve it on your own. So I'll solve the next upcoming problems in the next video. Thank you.